Okay, it's 1:30, so please, everyone, take a seat. We're going to be starting. So welcome to the Net Slicing BOF. As I said before, we have a very full agenda, so we will try to go through the chair slides rather quickly, and then we will be giving 10 minutes lost to the presenters. And as we have said before, we will be quite strict. We have a 1-minute warning sign here for presenters, and we will cut it 10 minutes after you start. So note well, as you know, this meeting is governed by the relevant documents. If you haven't read them, please go ahead and read them. That's important. So this is a non-working group forming BOF. When it was approved like that. And we want to thank our minute takers, so Sue, Kiran, and Ignaz. Thank you very much. Do we have a Jabber scribe? The idea would be to take questions from the Jabber room and relay them to the mic.
I can do it.
Ted can do it. Thank you very much, Ted. And then the blue sheets, we just circulated them. Make sure that they cross the aisle at some point, so in the center they also can sign them. And when you speak, please state your name clearly and slowly at the mic. You have there the agenda. We will be showing it later, but you can check it there. We uploaded all the materials to the IETF meeting materials site. You can download the presentations there if you want to watch them in your laptop. And we will have an Etherpad for note takers, so you can go there and check the notes being taken. The Jabber room is Net Slicing. Please note that it's not Net Slices. We were having the problem with the spelling, netslicing@jabber.ietf.org. And then the mailing list, which is Net Slices. That's the basically confusion. So please get the spelling right. Having said that, this is the agenda. We will first basically explain what's the purpose of the BOF, so we all understand that are on the same page on expected outcomes. And we will explain also how the IETF approaches this type of work, so we all understand where we're coming from. Then, as I mentioned before, we will have a set of speakers, and we have asked them to address 4 main questions. We will be talking about them later. And as I said, we will try and be quite strict with time, and we have assigned 10-minute slots, and we will try to enforce that. And then at the end of the day, at the end of the BOF, we will be answering the typical questions that any BOF needs to answer. We have slides about that. The purpose of this BOF, as we said before, this is a non-working group forming BOF. So the purpose of this BOF is not to form a working group, is to have discussions, gather information, and educate the whole community into the net slicing area. In particular, we ask all presenters, basically, to address the following 4 questions when they are presenting. What do you mean by network slicing? We have heard a lot of definitions, and people don't seem to be on the same page when they basically say network slicing. We want to basically, dig into that a bit more. What are the main use cases they have for net slicing, whatever their definition is? What IETF work or IETF, well, what IETF work is needed, either new or IETF work in progress, and then what non-IETF work is relevant. And our ID actually asks us to state that the fact that this working group, this BOF actually, is in the ops area doesn't mean anything special. It's just that, this BOF actually goes across several areas, and Benoit is basically acting as a host AD. So don't draw any conclusions from the fact that this is an ops area BOF. Adrian.
So most of you are IETF old-handers, and so this is apple pie, but some of you have been attracted in by the prospect of this new work, so it's worth looking briefly at how the IETF might approach this work. So firstly, the IETF works on the internet and its protocols. If you have work that's something else, then it's not IETF work. We work best with focused working groups, clearly defined problems in their charters, achievable deliverables, and not working groups that span multiple areas with wide scope. That has basically not worked in the past. Also note that the IETF is not a research organization, so we're looking for tractable problems for imminent implementation and deployment. The whole running code thing is key. So There is the IETF for bigger research problems, and there are plenty of other places to research. The IETF, on the whole, is not good at doing big, all-embracing, wide-scale architectures. We are best at on-the-wire type of protocols. APIs between software components, all inside one implementation, are basically out of scope. And we don't have a good history with APIs that are external. Although it's worth noting that Yang models fill that position. So we do have experience, we have external APIs, but we've also had some history with external APIs that have fallen very flat. So be a little careful with that sort of thing. Right, how to behave inside this BOF, obviously be civil. Listen carefully. What the chairs have discovered in preparing this BOF is that many of you use the same terminology for things that are slightly different. And it's very easy to talk past each other when you use a term and assume that the other person means the same thing. So be very careful to listen and understand that two definitions of the same term, you're both right, you're just using the term differently. Stick to your time limits. As Gonzalo says, we have a 1-minute warning sign, and I have an alarm clock here that will go beep at you at 10 minutes, and that is when you will stop. Save all questions for the discussion period at the end, unless it's a pressing question for clarification. If somebody has said something on their slide that is maybe a misspeak or slightly confusing, and you want them to clarify that in the context. But don't do the deep dive questions until the end. And those questions that are taken as we go along form part of that 10-minute slot. So if you believe you want to take questions in your presentation, then maybe 9 minutes is better than 10 minutes. Funny, when I page down on my screen, it doesn't change on that one. So we'll return to these 2 slides of questions at the end of the BOF, but it's worth just flashing them up here, things to have in mind as the BOF goes forward. So those were what is network slicing? What do you mean? Do we have a common view? Are there separate, distinct views using the same term, but they are very easy to represent as different views? And are those definitions clear? What are the use cases? So we should not be chasing absolutely every possible use case. We should be looking for killer use cases and use cases that there's a good body of opinion behind. They have to apply to the internet, otherwise why be here? And people must want them solved, not just agree that they're interesting. Then we're looking for what IETF work is in progress. Does that work need encouragement and tweaking, or is it just going fine? What other IETF work is missing and is needed? And then obviously, what work is there outside the IETF that we could utilize or maybe just redirect our efforts to? And then the other set of questions are more formal, and BOF enthusiasts will have read RFC 5434. That's largely targeted at working group forming BOFs, but we can reinterpret those questions for this BOF and come to, is there a problem that needs to be solved, and is the IETF the right place to solve it? Is there a critical mass of participants willing to work on the problem? And work on the problem doesn't just mean willing to put your hand up or hum in a BOF. It means willing to write drafts, review drafts, actively participate. Is the scope of the problem well defined and understood? So do people really understand what could be worked on and what might be out of scope? And if we were to list deliverables, could we be clear what they are? And then lastly, would there be a reasonable chance of success if we tackled these deliverables? That's it. And then does an AD want to say anything? Yeah. The AD says we've covered everything. So we will move on to our first presentation.
Perfect. So the first presentation, Georg, please. So you can drive this from here. Oh, slide that. Slide. Yeah.
Wonderful. Thank you very much. My name is Georg Meyer. I'm with 3GPP, and I'm the 3GPP CT chairman. And I will present, but after the last NetSlices meeting, we had a lot of discussions. Many things were ongoing during the last 3-4 months. And one of the major questions was, what input does 3GPP, like in its official documentations that it has at the moment from 5G perspective, what input does it have towards this working group or the work that is discussed in this BOF now? And I just want to say a few things ahead. We have major discussions at the moment on how to make collaboration between 3GPP and IETF easier and more collaborative. This is driven by many people, I guess. And tomorrow there will be at lunchtime a presentation where we go deeper into these issues. So these slides here only focus on network slicing. And tomorrow then I will keep most of the network slicing out of the presentation, as I assume interested people are here. I have too many slides. You will stop me. And I have the important slides first.
Can I just interrupt for
Absolutely.
10 seconds? Benoit Clay speaking. So you are the 3GPP liaison for the IETF.
I'm from the 3GPP side, the liaison towards IETF. Gonzalo is from the IETF side, the liaison to 3GPP.
Good clarification.
Yep.
Thank you.
You're welcome. So when we're talking network slicing, we're practically talking 5G. 5G is a project that we're currently pushing forward in 3GPP. And this is a very simplified form of our timeline that we have. Release 14 has just been finished. Release 15 is overlapping with it, is ongoing. We have a deadline for release 15 for June 18, 2018. Then we will grant ourselves, as we usually do, 3 more months to complete the still open issues. So we're practically speaking about September 2018, where we will have to have a first workable release for 5G, something that can be put into products, that could be put out there and would work. At least that's the plan. The deadlines that we have for release 15 and release 16, they are rather sharp. We always have sharp deadlines, but usually we can allow ourselves to linger a bit longer. For these 2 releases, that's not so easy. We have other influences from the outside world where we really have to make sure we meet these deadlines. So I guess one of my major messages that I want to convey to you today and tomorrow is, if IETF starts work on anything that is intended for these releases, then IETF should make sure that you meet these deadlines, right? So if you're saying you're working on something that is related to 5G slicing and you mean something that's meant for release 15, then you need to meet this deadline, else we have lingering drafts. We have lingering drafts in other working areas, like, for example, with IMS and ZIP. There it works sort of, but for this project, 5G, the deadlines are really sacred and we shouldn't touch them. So please keep that in mind. Where do we go under work related to slicing in 3GPP? What you see here is the 3GPP structure. So we have done the high-level requirements already in SA1. So this is for the whole 5G project, right? But also and what you see here with the bubbles is the slicing-related ones. The work is currently under quite good progress in the architecture group. There's a document, 23501. You will hear this again and again. You can read this. There's a lot about slicing in there. There the work is in progress. In progress means these requirements can change. And they will change for sure to a certain extent, but it's the guideline you can take. Then there's a lot of groups where the work is currently just starting. So those that are outlined here, those are the groups that will mainly work on slicing. SA5 takes a bit of a special role here, and I will have more slides on that. And this is now what I really wanted to convey it here. So the question I think that was asked to me and several people are asking is, does 3GPP currently have dedicated requirements for any kind of IETF protocol or activity related to network slicing? And you're asking at the moment, currently, right? So it's something that we have in our specs, something where I can, without any doubt, tell you this is there. And for that, the answer at the moment is no. There's nobody in 3GPP that could guarantee you that any specific IETF solution would be needed or would be taken for network slicing. Why is that way? We are just starting, or we're in the middle of the architecture work. Architecture work normally doesn't look too much or too closely into the protocols. And everything on protocol, security, orchestration related, that's either studies ongoing or is just about to start. So I don't want to speculate. I hope you don't speculate on what 3GPP is needing. What's foreseeable? Well, there are several scenarios foreseeable. I mean, UE2 core, core internal, RAN, and so on. Many groups, as you saw, will work on slicing in 3GPP. But of course, we don't know the outcome yet. So seeing this, I just want to say, please don't shoot the messenger. I'm not saying you shouldn't work on network slicing. I'm just telling you at the moment, I can't give you any concrete requirements, at least not requirements on the level that you would need to start off your work. But usually how the work is done is that IETF goes ahead with protocol work, and then when 3GPP finds their requirements, they're looking around and see, are there protocols that fulfill our requirements? This is at least one way we usually do the work. And I would say if this working group, or if the working groups that you envision to do the work, will go forward with network slicing related work, then for sure this will be something that we evaluate in 3GPP as possible solutions for requirements that we have. So now the rest of the slides is like practically I show a bit what we have in the working groups so far existing. So in SA2, the architecture group, we defined a network slice as a logically end-to-end network, and it's dynamically created. And when we mean end-to-end, then we really mean like it's the core network, but it's also the radio access network that can be sliced and that can be given either to a dedicated customer or for a very specific service as an end-to-end network. It's a standalone network like from a different operator. It includes the control as well as the user plane, radio access network anyhow, and also non-3GPP access networks such as fixed networks. Yeah, and then SA5, the orchestration work is done in SA5 or will be done in SA5. They just started their work. If you want to follow their work, there is currently, they have finished the work on the study work on a TR. A TR is always for us a technical recommendation. It's a study, it's nothing normative, but it's good to look at it. It's 28801, and they're now starting the normative work in several specifications. So this is not the only one, but 28531 might be one that you would be interested in. So you find those on our webpage, and I would encourage you to follow our work also on these specifications. In the specifications, you find what we really agree on in 3GPP. So SA5 again, because this was sort of an input that I got. I have 1 minute. Okay, then I just jump over these slides. You have more slides in here where I try to summarize the different cases that we for the moment foresee. And I hope this is sort of a background information where you get an overview. If you want to follow our work, once more, you have to look into the related specifications and need to find out what the requirements are. Of course, we can also work more closely together on a expert-to-expert basis. Thank you very much.
Thank you, Georg. Yeah, don't run with that. Alex?
Alex?
So, no. Come on, installing update. What the fuck is this? Okay, this is just too funny. Okay. So just very quickly, just 30 seconds. I was asked to clarify that tomorrow, the lunch slot where Georg will be presenting 5G work at the IETF, lunch will not be served. So if you go there, please grab something quickly and go there before that. Alex.
Okay, thank you very much for coming to this both. I will have half or some part of the presentation from the both proponents' point of view, which worked very hard in the last 3 months to build up 5 separate but interrelated drafts. And I will attempt to answer some of the questions, not all of them, as addressed by the chairs. However, after me, there will be 2 other presentations covering the other parts of the both proponents. There are plenty of slides. However, I would like to use only 3 to convey the 3 key messages. After that, I will accept questions vis-a-vis of clarification, but also substance. Now, slicing is happening now in a big scale. All the operators, to my knowledge, all the manufacturers and all the key research, industrial or academic research establishment are working on it in prototype software development as well as open source and designs. So it's a time to understand that this is coming, and the main emphasis now should be, in my view, to bring together all these energies in order to ensure that there is no chaos. At least slices will be compatible, interoperable, and usable. That's the main message. That's the reason why I'm presenting a few elements related to slicing. And as an end, this proponents group decided that the one definition which could be useful to be realized is a container of network resources, of network functions. Some of them will virtualize in the next period in large numbers, service functions, but also management and capability exposure functions, which will make this container very much usable in a context of delivering all the resources and necessary functions for one, at least supporting one service well. The issue is not to go for creating an overlay which supports all the services similarly. And in that sense, this concept has a long history, but currently it's hot topics in industry, as I understand. All the standard groups, including 3GPP, are working on it or starting to work on it. There is a major gap in the wireline area vis-a-vis of different aspects, but I will emphasize what is important. And anyway, these are references which I believe that will help the activity. Now, there are some key characteristics which need to be expressly mentioned about this emerging networking, which is mainly service networking capability. It covers all the layers from 1 to N of the OSI. However, the emphasis is in the way in which they are built, created in a management area. That's where this is where we believe that will add more value. And obviously it has to be done to include orchestration and many other functions, but it has to be dynamically created in such a way that will not interfere to each other. Obviously it has to have an operator and tenants, maybe multi-tenants per slice, but very importantly, this concurrent deployment of this isolated network have to have capability to support well at least one service. There is no point to do it otherwise. There will be services from non-IP type of service deployment to many other types of services deployed on the same shared infrastructure. The infrastructure might change, and we need to support all the needed isolation infrastructure. So for clearly, in our mind, there are a number of problems which as high priority should be able to be sorted out into an emerging working area in IETF. And we selected 10 out of 20, which we identified as the one which will make a lot of sense. Obviously, we have a little architecture which basically says that at the bottom you have the infrastructure, and that changing, and should not be precluding the work, which is the main work in network slicing, which is in the middle, which is basically management, dynamic management, embedded management operations and functions of and also the interface and interworking with services and the tenants and the orchestrate. The problems which we selected were done in such a way to ensure that we will have interoperability at the highest level between slices in the future, even they are defined differently by different manufacturer or different operation in the operator's network, which will happen anyway. As such, the middle part of the things which you want to solve are the management functions related to life cycle management, monitoring and discovery this large number of service networks with autonomic capability, and critically with end-to-end orchestration. By the way, orchestration includes coordination of around 100 separate other functions which need to be put here in order to ensure that these things are done. And all of them could be developed through new protocols. However, there are other key important things related to how this will phase the services. Therefore, a slice-aware young model to allow that to happen, as well as operation on slices to happen, it will be, including composition and slices, is absolutely essential. Key to it is to ensure isolation at the bottom, but also at the top of this stack. And that's coming to one point. Although there are many definitions, they are more or less similar. What is needed to be standardized, in my view, a uniform slice template, which includes components, which will be then used similarly, rather than semantically disjunctive, and in such a way the slices produced in, let's say, in 3GPP in a radio part, sooner or later, could be composed with slices in this area. Otherwise, there will be a problem. But the other elements which are important, which are listed on the bottom. So this is my 3 important slides. I have many details. I could stop now if you have clarification questions. If not, I'll continue.
I think it would be really helpful if you could clarify isolation, because I think people have different meanings of that.
Yeah, we identify this issue as magnitude, and we know that there are some already isolation at the bottom, namely resource isolation in some of the technologies. These are clearly used, but we are talking about isolation of the network function as a control plane, bearing in mind that 2 slices may have and should have separately defined network function as a control plane, because they have to support different services well. And this isolation has to be further enhanced and defined. And also, we envisage that a slice will have its own management, including management functions internally, and as such, two separate slices in operation or deployed may need to have a separation of the network function in order to not to interfere to each other. And this is a target, if you want, and this is a bit of more clarification compared with it. But slices are, in practice, a management concept in addition to the bottom layer related to the infrastructure, which is not new. Actually, it's a very old concept. Even IETF works on this sort of thing. Any other clarification questions?
Okay, there's 2 minutes, so use them as you...
Okay, I'll go quickly to some details of these problems. They are defined in one of the drafts. One group of problems related to the fact that management becomes an essential means by which this will be achieved. That includes life cycle management of slicing in terms of creation, also when they are deployed as instances, then when they have to be switched off and they have to release the resources, the network functions, and others for other use dynamically. In such sense, this problem becomes an essential tools to do it, and protocols to achieve it are needed to ensure cohesion vis-a-vis how slices are created worldwide. Very importantly, as I mentioned before, in addition to life cycle management, there are subject of control at different levels, as maybe 100 level of granularity of control functions which need to be covered, and they're exemplified in the diagram on one side. And the first diagram shows how this could be created, which is now very important. This has to be done with monitoring and discovery functions in mind autonomically. There will be many slices, and they have to be discovered in order to be used. Therefore, we need mechanisms and protocols to do that efficiently. That exemplified at the bottom of this diagram as one way to move forward. Very importantly, this slicing is mainly about supporting well at least one service. You'll find out more about in the next presentation. But there is clearly a need to ensure that these service models which are related to slicing are related heavily with young models. For specific young model related to slicing, which includes many other things than a normal one, have to be adapted. Now, I will just end to say that the key across all these problems will be a uniform model of dealing with slicing, in particular the slice template and the management capability and exposure, which will make this concept not only a reality, but protocols which will be used. Thank you very much. These are the 25 people who I have to thank because they worked very hard in the last 3 months, not only to produce the slides, but also in a weekly discussion to tease out what is important and what is not important. Thank you very much.
Thank you very much, Alex. And thanks for excellent timing.
I had 45 seconds more than
45 seconds over.
I
Okay.
apologize.
No problem.
Christina.
Thank you very much. Christina is next, please. So you can drive the presentation from here, and you have it there, actually.
Good afternoon, Christina. This presentation is going to talk about the main use cases and the gap analysis for network slicing. Here is our identified the network slice use cases. If we regard the network slice service, the network slicing can provide the network customization for some use case, such as the virtual custom premise equipment. From 3GPP perspective, the network slicing work in IETF can provide the resource assurance for some use cases such as the EMBB, URLC, MMTC, and MCS. And the network slicing also can support the implementation of new technologies such as the ICN. This is the use case of VCP autonomic OAM of a slice can make existing customization better isolated traffic engineering and flexible. For mission critical service, the network slicing can provide a dedicated physical medium, meanwhile provide the flexible control of subscriber management. That means the network slice can enhance the reliability, security, and flexibility. For implement the new technology such as the ICN. ICN is a long IP paradigm-based technologies. The network slicing can enable the ICN work together with the traditional IP-based service and provide the proper resource isolation between them. Let's considering the whole procedure of the network slice. At first, the system need to expose the network resource, and based on the exposed network resources, the tenant can describe what kind of network slicing requirement we want. This requirement is always the end-to-end, so it will be negotiated and coordinated among different domains, and then to construct an isolated and performance guaranteed network slice instance, and each instance also need to provide a certain of OAM for state monitoring or resource tracking. That means from the whole procedure, we can elicit 4 key requirements. They are slicing resource requirement description, cross-domain coordination, performance guarantee, and isolation, as well as the network slicing OAM. For the first requirement, as the network slicing domain controller, it should be able to describe the network resources it has, and meanwhile capture the requirement from the tenant, include the performance metrics, the protection requirement, isolation constraint, path restriction, and so on. The related work such as the Young Data Model, the CPP templates, the tiers-based and tiers could be used here, but some of them let up the resource abstraction and management on layer 3+, and some of them need the extension of specification of advanced service function to be invoked and their invocation orders. For the second requirement, the cross-domain coordination, different domain controller always need to coordinate with each other for the resource of configuration of some other informations. Some related works provide a hierarchical common platform solution for this kind of cross-domain coordination, but consider a more general scenario. That means different domain belong to different owners or administrators. So we think a flat or peering cross-domain coordination solution is needed in this situation. And besides this, the extension of network slicing specific behaviors and objects are needed. For the third requirement, the performance guarantee and isolations, different network slices should be isolated for the performance, security, or management reasons. There are a lot of related work here, such as the VPN, the segment routing, the DNet. We think the tighter coupling between the underlay and overlay and the enhancement to data plan and control plan needed. The last requirement, the network slicing OAM. Actually, the OAM itself has nothing new identified so far. But the problem is the network slicing has totally changed the granularity of OAM. We need to provide the personalized OAM for different talent. Meanwhile, since each slice may cross multiple domains and this domain may belong to different providers, that means we also need to consider the per domain OAM. And another possible usage is that is a lot of service implemented on a common slice. So we still need to consider the per slice OAM. As I already said, there's nothing new here for OAM. That means the technology-specific OAM tools, the overlay OAM and some other solution could be reused here, but we need to carefully considering the customized granularity of network slicing OAM. Here is our conclusion. We list the 4 key requirements in the horizontal, in the vertical direction. For the first requirement, the slicing resource and requirement description, we think a detailed network slicing specification, such as the performance metrics, protection, high availability guidelines are needed, and then accompanying YARN model need to be defined. For cross-domain coordination, a lot of protocols such as the BGP, GRASP could be reused here, but we need component data models for flat cross-domain coordination. For the performance guarantee and isolations, the extension work based on this related technology such as the VPN, the MPLS, and segment routing are needed. For the last requirement, the network slicing OAM, in order to perform the per slice, per domain, and per service OAM, we need to add some additional information to traditional OAM packages. That means we need to consider how to define, how to generate a recycle manager, this additional information. Meanwhile, we need to consider how to perform the OAM on multi-slice shared resources, how to autonomically discover the service function instance and their capability and the network slicing instance. Besides of them, we need to design a new working flow for the network slicing OAM and redefine the repository to store the coordination, the corresponding information. So the conclusion here is we need a new home to resolve the red regions, and we need extension work for gray regions. Thank you.
Thank you. Yeah.
So you're wonderfully ahead of time. So I can ask, could you spend 30 seconds helping me understand the difference between soft resource requirement and hard resource requirement in slicing?
Soft requirement, I think, and for I can give you an example. For the mission critical use case, it's a kind of hard requirement, a resource requirement. That means
It's okay, we can follow up offline.
Okay,
Yeah.
thank you.
So the question from the floor was does mandatory mean hard and soft mean sort of optional? And did you nod? I couldn't. Yeah. Okay, Dan.
Hi, good afternoon. My name's Daniel King. So I'll be presenting the applicability of abstraction and control of traffic engineered networks to network slicing. And I will certainly attempt to keep within my assigned 10 minutes. So I talk about a collective of engineers who have been working on abstraction and control of traffic engineered networks now. Essentially a framework that's derived from a set of requirements and a problem statement for solving traffic engineered problems. These are providing network virtualization, and network virtualization in some cases could be synonymous with network slicing. So when we started seeing sort of network slicing being discussed, and Alex mentioned that the cohort of engineers and academics have been working on network slicing now for at least 22 months, we thought it might be good to write an applicability document that kind of shows or demonstrates how ACTN might be used in order to solve some of the network slicing requirements. So what do we mean by network slicing? And these are sort of the ACTN protagonists. Network slicing is a transport network slice construct which provides an end-to-end logical network, often with compute functions and utilizing shared underlying physical or virtual network resources. This logical network is separated from other often concurrent logical networks, each with independent control and management, and each of which can be created or modified on demand. So essentially, these are our traffic engineered connectivity with function that may be compute or storage or content or network specific function that is bound to a set of reliability, performance, latency, and service capabilities. And we may also add a chain, sort of determinism, some kind of traffic steering or traffic flow in order to visit particular functions in a very specific order. How did we derive the overall requirements for network virtualization or network slicing? Well, we have a set of requirements documented specifically in a requirements document, but also a problem statement. These are associated across a number of dimensions: isolation, function specific requirements, performance, security, control and orchestration, which we can sort of put under the management umbrella, and also, of course, the need for multi-domain capability. And this, we've seen already multi-domain perhaps in terms of administrative regions or administrative systems in a horizontal fashion, but also vertically as well, where we've got a sort of cooperation of layers to provide connectivity and capability to some higher layer application. So in the ACTN framework, you would find this particular example on the right-hand side. Essentially, we've got our customer network controller, which is the consumer of the network slice. The network slice is provided by the multi-domain service controller, which is our supercontroller, our orchestrator. And the type of network slice is dependent on the type of service, the type of application that's actually running on top, so sort of the client layer. So it could be a fixed slice, which is not malleable. You know, there's no way to add or remove endpoints or modify or request additional bandwidth. Or we could go at the other end of the spectrum, provide some higher layer slice, which is adjustable, which can also be sort of controlled by some recursive functions. You could run a controller on top that can actually change addressing and even change topology and change the way that the flows are being managed on the slice that sits on top of some sort of server layer or underlay resource. At the bottom of this stack, we've got the physical network controller, and that could be for an optical network technology, it could be for some packet engineered technology, but in both cases, the commonality here is it's traffic engineered. So we were asked to talk about some of our use cases. Well, I've tried to highlight the use cases which are mobile specific, and these are documents that you can read, some of which have expired now, but were kind of used temporarily to help with the framework development. We had two documents specifically that talked about the mobile requirements, but as we've already seen, we can't talk about sort of hard or even soft 3GPP requirements because, as we've seen from the liaison and other previous discussions, there are no hard sort of specific requirements for network slicing per se. So these are generally the operators and their own environment, and maybe some of these requirements documented in these two mobile internet drafts might lead into additional requirements for network slicing. But of course, ACTN was not only developed for mobile environments. There's also a number of other use cases. These are addressed, or the problems, the scope of work are addressed in the other documents listed on the slide here. But things like sort of interdomain connectivity across multi sort of provider networks, inter data center connectivity, and multi-layer sort of client over server layer orchestration of resources. So what current work exists for ACTN? And this list actually is almost sort of filtered or shown in list of stability. So we've got requirements for abstraction control of TE networks. Clearly we needed this document relatively stable before we started developing the framework document. So the requirements in the framework document are essentially documents that will move into last call sort of, or are already in last call, have been sort of progressed through the IESG and towards RFC editors queue. So these are our most stable documents. Then we've got a number of other pieces of work. These are sort of ancillary. So we've got the abstraction methods internet draft. We've got our information model. There's a Yang model for the virtual network slice itself. And we've also started thinking about the OAM, essentially sort of telemetry, network telemetry. So how do we provide a feedback loop from the underlying network resource in order to have some kind of application awareness? It may be SLA specific. We might have to modify some server layer resource as the network changes, and how do we actually record and use that information? And there are also other documents as well which aren't on this list that talk about what type of existing Yang model could be used combined in order to have a model-driven approach when we need to set up or tear down or modify resources from that underlay/server layer. So there's a question at the mic.
No, I was just waiting to ask a clarifying question until you were done, and watching the clock, I assumed it would be soon, but finish first.
Actually, I'll come up for breath. How's that? And you can answer the question.
So earlier you mentioned how multi-domain had a couple of different meanings, and one of them seemed to be across administrative boundaries. From your later slide, I assume what you meant was cases like your multi-tenant MVNO, where there are administrative boundaries but a single network. But I wanted to ask you the clarifying question of whether any of these TE networks that you're describing with ACTN are multi-ASN.
I think in theory, the architecture or the framework supports a multi-provider environment. Whether or not that's something that's actually going to be deployed in the near term, I think it's still an open question. In this case, what you could have is each PNC could be operated by a different provider or a different operator. They would provide a slice of the resource to the MDSC that could be a broker, and then other sort of application enterprise, very large enterprise customers could then talk to the MDSC to actually ask for some kind of specific connectivity, and then depending on what each of the PNCs were providing, the MDSC would make an economic or technology selection.
In other cases of that type, do you anticipate somebody else would have a similar broker function that acted as an orchestrator above these to kind of create this super operation?
Yes, we could have sort of a parent MDSC. So although there's only sort of 3 layers, there's no reason why you couldn't sort of have a recursive nature, have a hierarchical
thank you for the clarification.
Architecture as well. Yeah. Cool. Okay. I think I'm almost there actually. So what are the other pieces of work that the ACTN sort of team are working on and the various participants? And I should highlight that the ACTN effort is happening in the TEAS working group with specific ancillary work occurring in the relevant or subsequent working groups. So Yang models, very important. Secure slicing and isolation of resources. How do you ensure that your network traffic is secure? Your sort of partitioning is kind of an open issue, and there are a variety of technologies that we could use in order to do that. Policy, who is allowed to request the slice? Well, that's kind of been out of scope. That's CNC to MDSC, but that's something that we need to start thinking about. Whether or not we need some imperative language to decide the type of slice or when to kind of switch in the event of some kind of failure. There's a working group in the IETF called SUPER, so there could be some policy language there that we can apply. And then the final point that I should quickly make is, since we've seen the discussion on network slices and this sort of growing interest in providing and managing network slices, clearly there's a need for requesting compute and storage, maybe content or function specific, when you're making the topology or the connectivity request. So in the context of ACTN, we feel that the framework and the subsequent architecture support that. We would need to write additional Yang models to sort of specify the type or size of the compute or function that you also required.
Thank you very much, Dan. Yeah, thanks. Yari, you're next. You can drive it from here.
All right. My name is Yari. I was asked to talk about how slicing and IoT relate to each other. And just very briefly go through some use cases first. So talk about critical services, the police or a power station. The one defining feature here is that you'll have to give them resources if you have them. Those services are so important. There's also a bunch of services or use cases where you have some real-time requirements, latency requirements. For instance, in a factory, it's like in a local area. And then here in the middle, the control of remote equipment. That probably have some latency requirements, but they are across one environment. Traffic systems probably have components of these previous cases to some extent combined. And then one final example here is the mass deployment of sensors, which both implies scaling to very large numbers of devices, millions or even billions. And then possibly also being able to, again, prioritize, but maybe this time, say, agricultural sensors, you might not need to have them like on this millisecond. It's okay to get them in a few minutes time, for instance. And as I was thinking about this, what can we do from a network, access network perspective to help some of these distinct use cases? And 4 things came up: separation, additional control, scaling, and then flexibility. I'll talk briefly about each of them. So separation is, first of all, could be like traffic isolation between different domains or traffic flows or users, but it could also be resource guarantees, like for the power plant or whatever, that you are given at least 50% of our resources, whatever we have. There's some control issues also. There's some desire to have some effect on how things are done in the network. For instance, for the low latency cases, one good example of that, I think, is the fact that if you have a mobility endpoint, you have a mobility service provided by the network, then you might, low latency factory case, for instance, you might want to have that in, near the factory as opposed to halfway around the globe or in the other side of the country. You also might have some DetNet style reservations for particular traffic flows. Scaling up or down, I have one example here. Up is kind of simple to understand, but down, that's also needed. For instance, there's lots of people who want to run, say, 5G or other types of networks within their warehouses or factories, and then it's important that you can actually bring it down in terms of practical ability and then commercial ability also to run inside a factory, or at least the key parts. And then finally, flexibility. You need to be able to tailor services to a situation. Again, use mobility as an example. Maybe you have some fixed nodes that actually don't need mobility. So maybe you can just dispense that for the purpose of those particular nodes, or more generally allow evolution and choice. You turn features on or off. You can run different types of software. You can run different type of networking technology. To some extent, at least. I mean, hopefully the interface to the devices is fixed, but what you actually do in the network might change radically as people innovate. So the other thing I was asked to define network slicing. I thought that there's multiple different ways of doing that, and people have all been doing this in this session. But I want to start from a slightly different angle. Like, what would be the possible minimal definition of the least thing that we absolutely have to have in the definition, or we have to provide? And I came up with this. So network slicing is network management, and it's not like QoS signaling between application components, but it's a management task pertaining to the treating of different traffic categories in separate virtual networks with independent resource technology and topology choices. And of course, that means there's some dependencies between different virtual instances and reality, of course. Like, you can't provision a link that doesn't exist. At least, I mean, you can go around, of course, but you can't provide direct links, for instance, when they don't exist, or low latency links when they don't exist. But that's basically a very simple definition of this. So having defined like the requirement, or having looked at the requirements and having given you a definition, I had some final observations to make. So I guess the question in people's mind is, what is needed? I'll just point out that not everything necessarily needs a protocol. I mean, there's different things here in this space, and much is doable with the existing tools, network virtualization, management tools, SDN, service chaining, ACT, and as we just saw. The question is, are there missing ones? And at least to me, I'm like keeping an open mind. It's not immediately obvious to me that, yes, I absolutely need that thing. But certainly there are some things that we can do, and there's always need to do more. If you think about something like orchestration, I'm sure we'll be working on that 20 years from now and still improving. So clearly there's more work to be done. But there's also a question of, like, how much do you want to do? We heard from George that like the timelines for this 5G work, for instance, are quite tight. So, you know, how much do you want to do before that? And you know, is there a chance perhaps that we might consider rather, you know, instead of a complete revolution, make an incremental change where you keep adding new things later also? That might make sense. And the other thing that I wanted to just mention or point to here is that there are some technical issues that one wants to consider. I don't have time to go through much of that right now. Jeff Tantura and myself wrote this draft on low latency services or applications, and some architectural considerations on those. And then there's a couple of points to make there, like, you know, be careful with your assumptions of, you know, this is only in a silo. Well, it turns out that, you know, in many cases you need to communicate within the silo, but also you need to get, you know, the software updates from over there and over the internet and so on. So it's not that simple. And also, there's a lot of talk about various kinds of QoS sounding mechanisms, and let's be realistic. There's a lot of history in trying to deploy similar kinds of designs in the past. There's a very nice article by Casey Claffey and Dave Clark pointed to from our draft, if you want to search for that, about the historical difficulties in deploying QoS, and those relate to not just technical things, but actually more business things. So with that, I think I'm done, unless someone has clarifying questions.
Okay, thank you, Jari. Thanks a lot. Stuart, you're next.
Has anybody not signed the blue sheets? Oh, that's quite a few.
Okay. So you're going to get a pink sheet. This doesn't mean that this is the IRTF, it's just we ran out of blue sheets, okay? So we had more people than expected. Stuart, the floor is yours.
Okay, thank you.
You can write. You can write. Okay. Just next slide and previous slide.
Okay.
Thank you.
So I'm a plumber, and I'm going to give a plumber's perspective on net slicing. What I'm interested in doing is getting the bits from A to B according to the characteristics that cleverer people than me have already set up. So what do I mean by network slicing? So for me, down in the implementation lower layers, data plane layers, it's a two-layer network where the underlay provides the resources and the overlay services the tenant. Tenant can have the degree of static and dynamic isolation that's needed to support both soft and hard slicing and the complete spectrum in between. So what do we mean by hard slicing? The model for hard slicing is that it's a separate physical network. But of course, you wouldn't want to, you may want to implement it like that, but you don't get any statistical multiplexing. So the trick is to figure out how we give the majority of the characteristics of a separate physical network to a virtual network, to a network implemented with multiplexing. Soft slicing is very similar to classic packet multiplexing. You can't read another user's traffic, but if the other user is on the network, then the packets bump into each other. The underlay, however, has to provide compute and storage resources in addition to connectivity. So what we'll be building is networks that have service function chain type resources as an integral function in the data plane, but also we want to be able to build a control plane using virtual resources if that is what's needed by the customer. So the overlay is specific to the to its demands on. The overlay has to be specific about its demands on the underlay, and we will need much tighter coupling between the underlay and the overlay than we normally have. So think of super RSVP, for example, or a segment routing approach that we'll be talking about more later. The underlay provides the tenant with a rich instruction set to specify the actions to be performed on the packets. That is to say, instead of just sending a packet somewhere, we will have to be rather more precise about what actions happen on it, both in the traditional service function chain model, but maybe in more specific terms as well. So what are the main use cases? And I'm only interested, again, focusing on the infrastructure. We want to be able to construct bespoke networks. We want tenants or applications to get the type of connectivity and the compute topology that they need to address their needs. We need to be able to construct assured networks. So critical applications would normally need a private standalone network. For example, emergency service networks and power distribution control happen on bespoke private networks specifically deployed for that at the moment. What we want to do is to bring the scaling of that we have in internet type technologies to those applications with the guarantees that we get with private networks. Deterministic applications that require something to happen now immediately because of some event. Deterministic applications, perhaps also in terms of visual type applications or consumer interactive applications that demand much better service than you get in the best effort internet style approach. And then there's regulated applications where you are required by law to provide some isolation characteristic. So what do we need to do is to transport, we also need to consider transporting new network types. So I'll put some pointers into this later on, but in the 5G space, people have been talking about possible replacements for IP, for example. People have been thinking of ICN as a possible replacement. What we really need to do is to build a transport system that can just take those in their stride. My bet is that IP will be the winner, but don't have the fight. Because if you have the fight, you spend a lot of energy, everyone slows down and things don't get deployed. So provide a service that can cope with alien networks as well. And also, of course, if we enhance the capabilities of the internet network, people will find new applications that we don't think of. So I regard this as being a way of moving on the capability of the protocols we deal with in order to provide a service that can support new applications. What work is in progress within the space that I'm talking about? Segment routing, service function chaining, deterministic networking, and ACN in Ts are critical pieces of protocol work that we are doing that can act as a tool base for us to develop things going forward. So what new activities? Well, I think we will need to enhance segment routing. We will have to give it more instructions, more capabilities to address different objects in the network and cause different things to happen at those objects. We need finer grained path specification than we're currently doing. At the moment, we can basically get things down to an object like a node, but maybe we need to go to a queue. We were going to have to integrate segment routing and service function chaining in a tighter way than we currently are. We're going to have to be able to carry such services over IP, and it would be nice if we could design one model and not have two other ways of carrying it. And we also need strategies to reduce the impact of head-of-line blocking, because if you are worrying about determinism, you don't want to bump into another packet. So we think that these new activities will allow us to build an enhanced VPN, which we've been calling in the project team VPN Plus, and I'm going to be talking a lot more about that on Friday. What non-IETF work is relevant to our deliberations here? Well, flexible Ethernet is one. That's a system for applying a hop-by-hop TDM infrastructure to Ethernet, and that is certainly a candidate for the underlay for network slicing. But that doesn't have the properties that I was talking about earlier on, where I get the statistical multiplexing. But if you want to build something at the extreme end of hard slicing, that is a good platform. ETSI have got this project called NGP, Next Generation Protocol. And it's an attempt at redefining both the network layer and the transport layer. I'm not sure if it will find traction. But if it does, then we should be in a position to carry it. And since one of their concerns is that TCP gives a problem, one of the properties of network slicing would be you could stop transport types that would interfere from bumping into each other. Information-centric networking was hyped as the way that 5G would work. It's really a type of CDN stroke search engine built right into the network layer. It's being done by the research community. It may or may not see the light of day, but a network slicing would be a way of implementing this on an existing fabric that would do many other things as well. And indeed, given that two, what I'm calling alien network layers have been put forward, slightly new ones will come forward. And so what we should do is to build a bearer service that uses IP to get the world up, uses IP to manage the world, uses IP or MPLS to carry things around, but can carry these new types. So we're building a sandbox. Relevant drafts, really this is just some background reading. The one that I particularly want to point you to is the first one, Enhanced VPN, and that will be presented in more detail, and we will have some discussion around the subject on Friday in the RTGWG working group. That's it, thank you.
Okay. Thank you, Stuart. Thanks a lot.
Stuart, can you answer or try to answer the question I had before about isolation, what you mean by isolation?
So in a hard isolated or a hard sliced system, I think it's such that if I'm running an application over one network, I can't tell that the other network exists. So we have static isolation, in my mind, is what regular VPNs are about, but dynamic isolation is closer to what deterministic networking is providing. That is to say, when I want to send a packet, I'm not waiting on anything else. I've got the resources I need, even though I'm sharing them. I've got the resources that I want now, and so I take no delays. And so if compute is running one of my sort of compute servers, again, I'm not waiting for it. I'm expecting it when I want it.
János Farkas Eriksson. Just an add-on to the ongoing work in other groups. The IEEE 802.1 time-sensitive networking features may allow you to have achieved TDM type of behavior in your network, and for the rest of the traffic you can get statistical multiplexing.
Right, and I'd like to add those enhanced sort of guarantees into the wide area. I believe that is the piece, one of the pieces of work that the IETF can uniquely add. Deterministic networking is the start of a platform, but I don't think deterministic network is really delving into what we might do in the underlying network itself, or what we might ask it to do for us in order to do better. At the moment, it's set up around kind of a best effort approach. I mean, you're using multiple paths and various other tricks, but wouldn't it be cool if you could ask for more from the network itself?
Okay. Thank you, Stuart. Hanu, you are next. Yeah, thanks. Next slide, previous slide, and you have the screen there.
All right, good. All right, I'm Hannu Flink. Now I'm approaching this slicing area from management and orchestration part, especially motivated to work about what's taking place in 3GPP, SA5, and ETSI. So that gives the background to the presentation. How this relates to the gap analysis that Christian presented a couple of tens of minutes ago. The presentation and the related draft relates to this cross-domain coordination, point number 2, and then mostly where we set requirements and expectations is in a network slicing OAM side. Because of multi-tenancy and multi-domain aspects, there needs to be something new there for filtering various types of KPIs. So answering the above questions that were given to us earlier, what network slicing is, it is a tool for implementing multi-tenancy, sharing network resources and sites among multiple tenants. It is a tool for creating dedicated networks for vertical markets, for very special type of networks, like what Jari Arko was mentioning, these IoT networks. They don't need necessarily everything what's there in the IP network side. And finally, it is a tool for service optimization for the operator to construct an efficient network for its own purposes and running his or her business. So what we take as a starting point, the network slicing as defined by next generation mobile network that was also adapted by 3GPP SA5 and ETSI. This is an information model taken from 3GPP SA5, which shows 2 domains. Here we have the connectivity service domain and then the network operator domain. A network slice provides multiple logical networks on top of partially shared network infrastructure. A slice may include several network components, and in 3GPP terminology, they are using network slice subnet. So one slice could contain these network slice subnets, multiple of those. Transport network in this model is one of these network slice subnets. And then below that, we associate to this grouping of network slice subnets, network functions. And as an example of course, stemming from 3GPP, there are these core network functions and access network functions. But you can imagine other type of functions there as well, also traffic engineering functions. A slice may be deployed or operated by a slice provider, meaning the network operator itself, or the tenant who requested. That depends on the relationship and the contract that has been made. Regarding the multi-domain aspects of slicing, there are 2 layers that are crossing across multiple domains. One is the service instance layer, and then the network slicing layer. And these definitions are taken from next generation mobile networks. The service instance layer is in the scope of TM Forum, which has been defined shared information and data models for that purpose. And it is also providing customer-facing services and APIs, as well as resource-facing services, service APIs and interfaces. They're kind of northbound interfaces from the network slicing manager towards the service instance. And then finally at the bottom we have these domains, and the domains may be technology specific, that ETSI is working there, IETF is working, and many other bodies are working on their own technology domains. Regarding then the multi-tenancy, how it impacts, multi-tenancy leads into notion of recursion. Here the picture shows again this communication service management function, network slice management functions, which is expected to come from the network operator, and then the network slice sub-network management function. Question is, are these APS1 and APS-A and APS-B equal? And if they are equal, then there is a natural recursion where we can put on top of communication service management and other layer. So orchestration creates slices and associates network functions to them and set up the connectivity between these. There are virtual network functions as well as physical network functions, and their lifecycle management differs quite a lot. So that makes a bit of a difference what can be managed under HCMano and what is the existing management systems. Nonetheless, because of the recursion, there is a strong need for service fulfillment and monitoring between these layers, especially what comes to capacity, security, quality of service, and mobility. It's not only isolation of resources, but also the ability to the operator to provide correct level of control to the tenants. And we foresee at least these crude 3 levels of control that network operator can provide to the slice consumer. The slice consumer is allowed only to monitor the selected KPIs. This is like a dashboard type of operation, if you wish. Then the slice consumer may have a limited control of configuring the given network functions and onboard some certified network functions from a catalog, or then it can provide a full control to the slice consumer, which is running possibly its own monostack. Of course, the last one is very rare one. It's a bit of exaggerated, but still there's a possibility. Nothing excludes that. So what this leaves us to is that there needs to be some management entity that is dealing with these abstractions and consolidating these FCAPs to the slice consumer. And this is what we are showing in the draft. We are introducing network slice management function, which is sitting on top of HCMano, and then on top of network management systems. And these network management systems, they gradually grow towards these virtual network management functions as we increase the functionality of these network slice subnet management functions. And here you can see the dependencies, interfaces, and possible places for protocols that we foresee to be important. So to wrap up, there's a lot of work ongoing in the non-IETF area, especially in management aspects. But in order to ensure whatever work IETF is taking, we need to align this work. And what parts need to be aligned are the abstractions and data models. They need to support multi-domain and multi-tenant operations, interfaces between the relevant functions, support for recursion and varying levels of exposed control for tenants with different capabilities. And then we pinpoint that there is this need for functionality that consolidates the OEM FCAPS performance indicators that slide consumers. This is the concluding slide.
Okay, thank you, Hannu. Benoit.
Benoit Claes, a clarifying question, please. So if you go back to the previous slide, sorry. So can you clarify what you want to solidize in the IETF? Because it seems that you want to have a full NMS OSS system. With this picture and one of the first picture we saw in the problem statement, right, where you spoke about template management, about network slice repository, lifecycle management, end-to-end orchestration. domain orchestration, cross-domain for different domain, right? Maybe not cross-operator. And what do you want to do? What is your goal here in the IETF? You want to have the full NMS OSS in the IETF?
No. Well, I'm highlighting that these bold blue lines here. They are showing the interfaces that we think need to be defined here.
And I'm not too clear what are those interfaces.
Some of them are non-existent. In the concluding,
I like that.
This is work to be done. This is both. So if you look at the concluding slide set, there I state what I'm expecting. Data models, compatible abstractions, these interfaces, support of recursion, and then means to consolidate these FCAPs.
Right.
These are the elements in order to implement it. The framework of what I was showing.
The clarifying question that I'm after is interfaces, okay, APIs, okay, typically models, fine, between relevant functions. I'm not clear what the functions are. Is this something that you want to have slice management on devices?
No.
Or
no.
Cross-domain?
Cross-domain, yes. And the cross-domain part comes, where do you put this network slice management? We are saying that it's on the service instance layer, which might not be of business of IETF at all. As I showed in my slide, there is this TMF forum which is working on that.
Okay. Is that a clarifying question?
Yeah, quick clarifying question. Srigandavelli, Cisco. So do you foresee any new protocol definitions when you say standardization of interfaces? Is it new protocols that you plan to define or extending some existing
protocols? No, we are not suggesting any new protocols, possibly extensions. We should start from these that we are able to support this recursion and multi-domain aspect. Multi-domain creates some policy issues. We are not supposed to be releasing very sensitive information to our neighbor, and we need to be able to encapsulate the data models.
Thanks.
Okay, thank you very much, Hanu. Okay, with that, we concluded our presentations, and now we're going to have open discussions. So I will be showing this slide, so you remember the questions we were asking. So if people going to the mic want to address them, that'd be great. Comments on the presentations we saw, they are also welcome. And please keep in scope and be concise, because we don't have so much time either.
And just to add, there's nothing to preclude presenters from also going to the mic to make their own points.
Hi, Tal Mizrahi, Marvell. So I have a question from the first speaker, George. We understood that 3GPP is not really waiting for our work, and they probably know how to define the slicing models and architecture on their own. So my main question is, who is the target audience of the work that we discussed today?
Yeah, Georg, go ahead.
Maybe I can quickly respond to that. So I'm not sure when you say the target, whether you should, like, say, define the target. My understanding from IETF so far is that you have enough self-esteem usually to start to work on your own. And then, of course, you got a lot of presentations now, what other groups are working on, what holes need to be filled maybe. So I think if you keep these things under your radar, most likely your solutions will be chosen later on when architectures are defined in more detail. I can't promise you that these solutions will be taken at one point, but at least if they are there, they need to be taken into consideration, and we have evaluation processes where we do such things. Thanks.
Norm Finn, Huawei. There's a scale question that can really affect the amount of work that we need to do, which is, are we talking about a router or a link serving 10 customers or 1,000 customers or 1 million customers?
Yeah, so I'm not empowered to answer that, but let's just do a question to the room. In the room, I'm going to do a three-way question, 10, 1,000, 1 million. Which do you think is nearest? Who thinks it's nearest to 10 customers per link stroke node?
Sorry, I would like to answer.
So we'll come back to you. Who thinks it's nearer 100? Okay, you don't get the question. So Norm was asking a scaling question. How much are we slicing? Are we slicing in the order of 10 customers utilizing a link or a node, or are we looking at 1,000 or 1,000,000? Do I mean 10? Yeah, 10 slices, or 1,000 slices, or 1,000,000 slices. So 10. I see of the order of 20 hands. 1,000. Similar number, 1,000,000. There are only 3 optimists in the room. Okay.
And for people remotely, I mean, there were anyway very few people raising hands anyway, and we have a full room. So Alex, you wanted to address that briefly, or?
Yeah, I would like to address it. Before VPNs were invented, or the question was how many, what's the scale of it? As the technology to implement it evolved, and now is the norm, that moved from few to many. I think that as slicing will come to the same view, namely sooner or later it has to be properly implemented and mature at all the levels, in particular management, as it was mentioned, and then the answer will be very many, because this is going to be sooner or later the abstraction. We don't need any other things on which all the other elements could happen. That's another way to look at it.
Okay, thank you, Alex. Daniele, please.
Daniele Ceccarelli, Ericsson. I would like to try to make a summary of what I heard in these 90 minutes.
That'd be perfect.
Then let's see how many people agree with me. I doubt that. We have different types of domains. Let's say radio, totally out of our business, at least for the moment. Transport, we have different requirements. Someone believes they are almost all addressed with actual tools available in IETF. Personally, I agree with them. Some others believe something is missing. We can work on that. I wouldn't say there is the need for new, huge work, but probably augmentation to what is already there would be enough. Then the cloud. When I speak about cloud, I think of NFVI, packet core out for the moment. NFVI, this is where I see a little bit more meat. We have a lot of solutions, but silos. Maybe we could start working to make these domains work together. Again, personally, I believe it's just a matter of augmenting what is already there. I see ACTN as a perfect starting point to use the young models we have in ACTN, topology, T-topology, augmented with NFV information, NFVI, things like that. This is my view and my summary of.
Okay, thank you, Daniele. Before we go to the other mic, I think he was waiting longer.
Right.
Please.
Liang from China Mobile. I don't have really specific questions, but I would like to share some of my observations, maybe helping the room understanding what we as a BOF proponent understand as network slicing and what 3GPP really think network slicing is. So in 3GPP SA2, it's clearly state that network slicing defined by 3GPP only include RAN access network and packet core network. So this is has been written down in the latest version of 3GPP SA2 document. And also in SA5, there are actually requirements in a specific section that saying the network slicing management system defined by 3GPP SA5, there are two options. One is should relay or should advertise the link requirements to the transport network system, management system, to actually ask the transport network system to decide which transport topology or technology should be used for the linkage between the RAN and core network. And option two is assume that the 3GPP network slicing management system has an approach to know the transport information to decide itself. So that's clear to me are actually considered some sort of requirement for the transport area to work on, of course, in terms of this information models that can be provided between these two systems. And also, another point of view I would like to share in responding to Hanu's presentation, we can discuss this offline as well. So I actually don't agree regarding transport network as a NSSI, which is network slicing subnet instance, because here I quote in SA5, it says a NSSI may include core network only, or RAN only, or both. So this actually aligns with the definition in SA2. It does not include transport network. So my understanding, network slicing, this two words in 3GPP only include RAN and packet core. And IETF network slicing, although using the same exactly words, mostly mean transport. So there are no directly overlap between these two definitions of network slicing. And that's my understanding, and that might clear many people's mind what we're talking about by network slicing in terms of network domains. So, yeah.
Thank you. Thank you very much. Jeff, you're next.
So, with regards to scope, I'm probably talking as A.B. Shepherd for the both. I think focusing on 3GPP is wrong. Number one, there are no requirements coming from 3GPP to us yet. Number two, if it's very much 3GPP focused, it will result in deficient solution focused only on radio and packet core. So there are additional things that lead to network slicing. It's not new. We've been doing L1 VPN, L2 VPN, L3 VPN for quite some time. However, the network slice definition has always been a transport layer. We've never looked into resources, right? If you're trying to do L3 VPN, you're not losing a number of CPU cycles on P router. The difference now, the network function virtualization brought these functions. The mobile edge computing or multi-access requires proximity-aware workload placement, which requires whole notion of network slices. What it really means in terms of resources, networking resources to place workload, to reach workload, to deploy it rightly. So we should focus really to address industry problem rather than focusing on 3GPP or MEF or any other organization. And the scope should be as such. Not really. They are not telling us anything, so we are not doing anything. From my perspective, from personal perspective, it's wrong. We should focus on industry needs, not on particular SDOs.
Okay. Yeah. Thank you, Jeff. We'll stay there, and then we will go to the next mic. So, Dave.
Okay. Dave Allen Erickson. One of the things we want to avoid, I think, is the mistake of conflating all of the requirements of network slicing as needing to be satisfied by all of the network. Because when you look how networks are built right now, there is the RAN component, the backhaul, the packet gateway, etc., the provenance of 3GPP. Technologies like CIPRI, the concept of the baseband hotel, etc., are actually going to suggest that an awful lot of these functions are co-located, which means many of the slicing requirements are actually going to be isolated from the underlying network, and many of the critical control use cases, such as critical machine type communication, etc., are actually going to be handled by that co-located equipment. And the same stringent requirements are not going to be required in the network that extends beyond that into the wide area network. So if we actually think we are going to extend all of these very demanding use cases ubiquitously across the network, we're solving a problem that does not need to be solved, because this is really about intelligently arranging the deck chairs to address things as much as anything else.
Thank you, Dave.
Shri, Kundavali, Cisco. So I have one general comment on provisioning domains. So in multiple MIF working group, MIF, there was one work item called multiple provisioning domains, MPVD. So a lot of slicing concepts are present in that work. Somehow that work didn't move forward, but I really want the BOF group to really look at that work that was done in the past.
Okay, thank you. Warren.
So, Warren Kumari, maybe what Dave said clarified this for me somewhat. I'm not sure. A large amount of the discussion seems to feel as though it sort of assumes that the network exists everywhere and looks the same everywhere. So if it's this like thin layer of stuff which you put all over the place. And it doesn't really work like that, right? Networks get built so that you have more capacity where you need it, and it gets built sort of according to what the existing use is. If you expect that you can go along and say, I would like some network capacity from here to here with latency that just isn't doable because the network doesn't look like that, or more with sort of QoS type profiles that look like this, that means that the network needs to be built with way more capacity than currently exists, or with the ability to punt some set of people off when this comes along. This, I think, means that things are going to end up way, way, way more expensive. And I think that a lot of the sort of, we would like to be able to do X assumes that the network is going to be there. And in order for the network to be there, you need to spend way more money. So if people are okay with that, maybe that's fine. But I suspect providers are not going to want to build to that sort of level, with just ubiquitous capacity everywhere, because then it's fairly easy for people to move to my competitor. And then suddenly, I'm left with this extra space. Don't know if that was coherent.
Thank you. Yes, please.
Igor Bruskin, Huawei. I just want to say that I fully agree with Jeff, and I disagree with the, I'm sorry, forgot the name, China Mobile gentleman. Basically, when he's saying that a network slicing is only concerns the packet switching layer and transport network is not involved in the network slicing, I disagree with that. This is how things may look to the network slice user, but when we talk about network slice isolation and all kinds of constraints and like bandwidth and delays, reliability, stuff like that. So this would intimately involve management of transport network. So we will really have to deal with that.
Thanks. Thank you. Please.
Yeah, Jedong from Huawei. I have a similar opinion as Igor has. We are expecting the requirements from the 3GPP on the network slicing, and at the same time, IETF working on the transport network, and we will expect this capability of the network slicing to provide the service for the vertical industries for the more general use cases also. So I think this work should be useful in IETF.
Okay, thank you. Benoit.
Benoit Claes, is it possible to go back to the problem statement slides and show one diagram there?
To which one?
The one done by Alex, please. Yes. Slide number 4. So I would like to, again, try to understand what is required from the IETF in the NMS OSS part, this one there. Yeah. So I see all these arrows there. Typically, what we're doing is we're dealing with networking in the IETF, all right? And there I see like the network slice management orchestration, and I'm wondering if you want to have all these done in the IETF, and if not, which interfaces. To come back to the orchestration presentation, the gentleman spoke about APIs for service functions. So what actually do you want to have here from the IETF?
That's a very good question. First of all, I would like to say that I am fully in agreement with Jeff here. There is no point to wait for requirements from outside to start work here. Bearing in mind that the slicing activities are mainly about managing the transport network, but even more to ensure that this transport network is supposed to carry well the traffic for at least one service well, and not for everything on a bay time. But to answer the question is that we're talking about embedded management protocols in the network. And that includes, in my mind, new ones which are need to be created in no particular order. The coordination of all this slicing under the name of orchestration, either in one domain or multiple domain. It's essential. Second, protocols related to discovery and monitoring of this slicing, which are very dynamically created. which need to be created autonomically, not by hand, and so on. Also, new protocols are needed for the creation of the resources, the network functions, and other elements, service function, the management, to create a slice and then instantiate it, which means that traffic then had to be directed to that slice when it's instantiated. New protocols are needed to allow elasticity of the slices, i.e. triggering elasticity when the service requires more resource or less resource, more or less network functions, more and more are going to be virtualized anyway. This has to be dynamically created and enhanced. These are pure management of the transport network, which in my view, it is part of the essence of IETF. And this is where this work will add value of substance. I think that also it's overestimating it too much to look only at the traffic engineering. This is beyond traffic engineering to some extent. And this is probably the complexity which has to be dealt. Underneath, to answer the question about isolation and others, there could be many type of network, SDN-like, non-SDN-like, many guarantees of different kinds. We should cover all of them because at the end of slices, we should cover all these parts. And it's a time to find out what is mature in terms of solutions. But in my view, solutions for these problems are needed in the next 2 years in order to catch up with the industry, which is working in parallel anyway.
Can we go back to the question, please? So to my question, you want to standardize the arrow over there, the one at the bottom, right? Only that one in the IETF. Is this correct?
No. I also mentioned the arrows above, namely how your tenants is supported, as well as the protocols inside the middle box, green one, which are necessary to ensure sooner or later that 2 slices could be operated and uniformly.
So basically, you want to have a full NMS OSS, right?
But an embedded set of protocols. This is not full NMS NSS because it doesn't cover all the FCAPs. And also it doesn't show how this will be linked with the classical, let's say, the existing OSS, which is not the case. Therefore, I'm looking only for these slice-focused embedded management protocols which are needed. And in my view, they're needed urgently.
Right, so I've been involved in those NMS OSS, at least those aspects of multi-tenant, cross-domain, cross-controller, part of FCAPs. This is really complex. Basically, what you want to have is a full kind of product which are sold to do, if I take example of an L3 VPN, right? So this is what you want to have by having the arrows at the top, right? Because whenever you start to go between the slice provider, this is like at the top of the NMS OSS, I want to request a service. It should be multi-tenant. It's going to go to different networks. Somehow, it's kind of easy to create those APIs because a Yang model is an API, right? Create slice, delete slice, extend slice, right? I can do that very easily. The hard part is whenever you have to map this to the different technologies. In the routing one, we saw segment routing, we saw TEAS, we saw VPN plus, we saw all this. But this, I mean, this is like code that we have to write with if statement. If I'm a transport network, and by the way, the slide definition is also about access and data center. So if data center, if transport, if this technology, then I do all this. So this is code in the end. That's what I'm starting to say, that it's a full NMS OSS you want to have here standardized.
It's not quite. I think that the number of items which could be standardized in order to allow interoperability and operation on slicing uniformly are much smaller than a big OSS. Second, obviously, this mapping which you mentioned has to be done. It's probably per slice, given the fact that a slice has to compose to be specific to one network, SDN, like, for example, like ACTN does, or not. So this mapping have to be multiple, and indeed is part of the job. Now, how to put together all the things is part of the process which I call the template, which need to be instantiated and used uniformly. Otherwise, a slice in 3GPP will be totally different from a slice in my pocket. and so on and so on. So we need a level of interoperability, and that's where, and one thing which I disagree with you, it's not so hard. It's just complex.
We need to move on. So we have 5 minutes. I'm cutting the lines. So you guys please keep it below 1 minute. Jeff.
Without ball exhaustion. So the key success factors for anything are consumability and traceability. And to bring it directly back to IETF, any solution in slicing will require recursiveness. It's multi-layer, multi-domain by definition, which will bring some requirements in regards to YANK and way we do data modeling. And this should be discussed about now because we are producing these models. Number two, our APIs are as good as our data models, which brings back YANK again. We expect data models or API generated from the data models to be used to create slices that might not work as we expected. So there's immediate work and attention on IETF side to provide right set of APIs and rightly structured data models to be able to actually create and instantiate slices.
Thank you, Jeff. When I said I was cutting the lines, I meant I'm cutting the lines. Yeah. Please.
Thanks, Chen Xiong. We have a 7-layer architecture from the OSI. From the different layer, we can define a different slicing. For example, from the CPPP, the most focus on the layer 2 slicing. But for the IETF, we most focus on the slicing up to layer 3 layer. I can give an example. In 3PP, we define the mobility management based on layer 2 technology you can hand over. But in the IETF, use mobile IPv4 or IPv6. The totally different technology solve the same problem to mobility management. Also, if we said VPN, in IETF, we have at least a different 2-layer VPN. One is layer 2 VPN, another is layer 3 VPN. Even some people say that peer-to-peer technology can be used to create a VPN on the application level, like Skype, Immute, BitTorrent. So from my point of view, if we start slicing, we first restrict which layer we will be focused on. Different layer have a different technology and requirement.
Okay. Yeah. Thank you, Aaron.
Aaron Falk, Akamai. I'd just like to point out a piece of related work to this. Over a big part of the last 10 years, I worked on a National Science Foundation, U.S. National Science Foundation funded research network called Genie. You can find it at genie.net. It is a national scale collection of cloud computing interconnected by layer 2 networks that are dynamically assignable resources. This was the first time that I'd heard the term network slicing, so it's been around in that community for a while. There's running code and opportunities for people to play with the mechanisms there for doing resource discovery and stitching together of network segments. This stuff has been around in the Research and Education Network for a while. Turns out that it's really hard when you start wanting to make guarantees. But if you're trying to provide best effort end-to-end connectivity, possibly with a small pool of reserved infrastructure for special users, that kind of thing can be done, and it's actually running now.
Okay.
Just a quick comment to that. I've been around the same communities, and it's worth noting that it's actually never seen a use case outside of experimentation in those communities, which is a good point to what Warren was saying, that it's fine, good and fine to build these things, but you got to actually have a use for it.
Okay. So we keep on the same mic, and we will finish with Yari.
One thing I have to say about what was presented as a set of use cases, it's so large and so encompassing that I just cannot see how a piece of work for above can be isolated out of that. Especially if we start to add non-3GPP historic cases that predate this and which clearly associate a network resource plus some non-network resource to it. Because Genie is not the first, is not the only one. A VCP sub-product as a whole is a classic case of slice, and it predates the 3GPP effort by years.
And there were other efforts as well. So especially if we keep this as an IETF work, which is not wholly dependent and wholly serving 3GPP, and if we keep the amount of wish list, which Alex presented, I cannot call it anything else, we're never going to get anywhere. This needs to be cut down to size.
Okay, thank you. I mean, just to clarify before we go into Yari, because there's been like 4 or 5 of you talking about that. Obviously, this is not about 3GPP, and that's why Georg made the statement. And as any other IETF both, if we find work that is relevant for the internet, the IETF will tackle it, regardless of whether or not it comes from 3GPP, Broadband Forum, MEF, what have you. So I hope this is crystal clear. Yari.
Yari Eriksson. So I wanted to respond to Warren's comment earlier about the costs. And, you know, obviously you can't request things that don't exist in reality. So, you know, that things will be limited by that, but also that will be limited by the usual, you know, market behavior. So things that are harder to get by are going to be more expensive. And if lots of people request that and they actually pay money for that, then that's great. You know, if less people do that, then you know, it's you know, more resources available for those that actually do require that particular thing. So I don't think that's a major concern. I would rather argue that you know, if there's a cost concern here, it's more about the complexity, as pointed out by the previous speaker. And I am you know, it's IETF does a lot of great work in this space. Also, others do, open source organizations and so forth. I think we need to continue that work, expand on that work, figure out what additional pieces we need. But we should not go totally crazy and you know, attempt the impossible and this or that and all the possible requirements. That's, you know, maybe too much, in my opinion at least. I can't fit it in my head. Thank you.
Okay, thank you, Yari. So with this, we close the mics, and we are moving to, as Adrian mentioned before, the 54-34 questions, which even though they are basically geared towards working group formings both, but this is the questions we will ask. You want to go ahead?
So let's sort of start this with a hum. Please hum if you believe you are now more intelligent than you were when you came into the room. Okay. Please hum if you are now more confused than you were when you came into the room. That's a few hums, but not devastating. Let's jump to the third bullet here, I think, which is the scope of the problem well defined and understood? So really that comes back to, do we have a clear understanding of what net slicing is now, or at least do we believe that there is a problem called net slicing that we need to investigate further and pin down? So let's have a hum on that. Do you think that the scope of the problem is well understood? Wow, have I gone deaf?
Well, I mean, we should probably take the opposite hum as well. So if you don't think is well understood, please hum.
Okay, yeah, so Greg is asking a third hum. Do you think this problem is now better understood? Hum now. Okay, so the people who thought it was well understood already thought it was well understood.
And for the note taker, I mean, we got a much stronger hum on the fact that it's not well understood.
So let's work backwards then. If we were starting work on trying to nail down what we mean by net slicing and what work needs to be done, who in the room would be willing to actually work on this by writing drafts and reviewing drafts, not just showing up on a mailing list or so on? And you can put your hands up for this one. And I see pushing 30 hands.
Yeah, it's a substantial amount, yeah, around 30.
Right. And then we beg the question, why? Why would you do that? Is this a problem that needs solving in the IETF? Okay, so Is this an IETF scope problem and a problem that actually needs to be addressed? And you may hum on this one. That's a pretty quiet hum, so we better do the opposite. Those of you out there who think this is not a problem that needs solving in the IETF, please hum. Yeah, also quiet.
A bit louder, but quiet anyway.
Greg just loves asking questions.
Yes. Okay, I might explain why I didn't ham on any of the last questions, because I think that what to me was clear in the presentation of net slices and the problem statement. There is not one problem. There are a bunch of problems, and we can look at each of the problem and decide whether we take this problem or take that problem. Because if somebody asks me, are you ready to take net slice problem? No. But there are a lot of problems that I will be interested to work on that go under the net slices and then being clearly stated here.
Clear. People seem to agree with you. We better do this.
Yeah. So I think we basically, had the questions, the answers we wanted, and yeah, I agree with you actually that yeah, it's not like on off. But we cannot have 30 questions now in 10 minutes. So well, what we think we heard is we got a few use cases, different ideas. I think the conclusion or the agreement seems to be like people agree this is a complex issue. It's clearly not well understood still by the hand we got before. And then basically what we need to do is talk to our ADs, and let me stress again, it's not only Benoit and Ops area. We will talk to the ISG because this goes across many areas, and basically then the ball basically will be with them to take the next step. So to be very clear, what the chairs will do next is that we agreed to post the minutes, and after that, we get a beer. Benoit.
So the hard task to try to summarize this. So I took some notes. What I want to do is, what we do at the end of the week is that we've got an IESG IAB meeting in which we're going to collectively review this and give an answer. So, however, I took a couple of notes here. Okay, we noted your conclusions. They're about right. I see a lot of people in the room. That's a good thing. And by the way, thanks to you guys, you can start drinking. So network slicing has got a specific notion in 5G, but we heard that we don't have any 5G requirements at this point in time. I heard as well that we might have some use cases that are not 5G related. And somehow I'm not surprised, because when I see the definition of network slicing in the problem statement, well, it's so large that basically it covers everything. So the location, it's access, transport, DC, it's compute, storage, networking, it's a data plane, control plane, management plane, it's physical, it's virtual. So I'm sure there are use cases that are non-5G. So the key thing is to find the one that we want to solve if we want to solve them here. But I still see anyway different definitions of network slicing. I've seen the one from problem statement, I've seen one in 3GPP, I've seen one in ACTN, I've seen one in routing. So these are, again, maybe different view of the same concept, but it would be great to try to harmonize this. What else? I understand that, and I come from ops, so I will mainly speak from the ops point of view in this case. So I understand that we want to have slice management, and that makes sense, right? We want to be able to create slides, to extend slides, to delete slides, slice, sorry. We want to have the ability to do OAM, right? Because in the end, we do network slicing to have a service with specific characteristics. Now, on the NMS OSS part, I'm confused here. Because typically it's not something that we do, and to be slightly provocative and to make people react right on the mailing list, so keep working, is it seems there's a bit of I want a pony here. I want a button which says
I want a network slice, and because I've got this API that says give me infinite bandwidth and packet loss of 0 and delay of 0, I will get this automatically, right? But behind this NMS OSS, as I call it, there's a lot of things that must happen, right? And as I mentioned, creating a Yang model to say create slice is like piece of cake, right? But how do we map it to the network below? That starts to be very difficult, specifically because of the different location, the core, the transport, data center, because let's not forget there is like compute, storage, networking, and maybe the RAN as well. So what else? I heard that there are parts that are being worked on in the IETF, in ACTN, for example, in routing. And I've got 1 minute, that's good. So in my 1 minute, I heard also from the IoT plantation that there are nothing required. So there is like maybe a mix between the two. I'm quite happy that nobody mentioned I want a new in-cap. Good. And I think that's it.
Okay. Thank you. The last point is like what the proponents should do while you are doing your next step, taking it.
So we had a couple of discussions here. I've been also provocative to make people react, right? I propose that you use this week with the proponents and actually even with the people who are not proponents to make sure that they agree as well and coordinate on the points that we've been discussing this week.
Okay. Thank you, Benoit. Thank you, everybody for coming.
Thanks to the minute takers who had a hard job. Thank you to Jeff Haas for the loan of his timer.
Yeah. The meeting is adjourned.
When we ask everybody's blaming that's not right. That's not fair.
Has somebody got the extra blue sheets? Blue sheets?
There's a blue sheet somewhere. Oh yeah, that one. So if no, yeah. Daniela is bringing it.